Hello, everyone, and welcome to today's webinar titled Practical Trends in Big Data and Analytics. Our speaker today is Myles Brown, Senior Cloud and DevOps Advisor at ExitCertified Tech Data. With over 20 years experience in the IT industry across a variety of platforms, recognized as an AWS Authorized Instructor Champion and a Google Cloud Platform Professional Architect and Instructor, Myles has delivered award-winning authorized IT training for the biggest cloud providers. Before we get started with the webinar, let's cover the functionalities. During the webinar, everyone's microphones will be muted. So if you have any questions, please find the Q&A box at the bottom of your screen. Enter your questions in that Q&A box at any time. We'll try to get to them during the webinar, and if not, we'll have a dedicated question and answer session at the end of the lecture. Today's webinar is being recorded, and we'll send a copy out to each of you by the end of the week. I'm also going to share a promo at the end of the webinar, so stick around to learn a little bit more about that. All right, Myles, you can take it from here.
Okay, thanks, Michelle. So everybody, my name is Myles Brown. I work at ExitCertified, which is part of Tech Data, and what we do is authorized training. And so we're partnered with over 25 major vendors, the big cloud vendors, IBM, Oracle, VMware, Cloudera, Databricks, a lot of different vendors. Primarily, lately I've been more of a cloud guy, but I really was more of a big data guy before that. And so really, on the cloud side, I'm dealing with data and analytics a lot. And I still keep watch over the big data classes, the Cloudera classes, the Databricks classes, and I'm in constant contact with our instructors there, and I've interviewed a few of them to get some insights for this presentation. So this presentation is going to be about practical trends that we see in big data and analytics. So we're going to start with just a few definitions, make sure we sort of level set, everybody knows what we're talking about. Then we'll talk about forward-looking trends, and one of the things I find is that if you just go and Google, trends in analytics, 2020, what you really get are, 5 years out trends. So, hey, by 2025, 80% of companies will have this or that. And it's, it's always really forward looking, right? And so what we want to concentrate on more is the trends that we actually see happening. What have we seen the shift in our students in our big data type classes? And that shift from just looking at big data to really getting into machine learning and AI. And then we'll end off just sort of talking about where to learn more. And like Michelle said, we'll have a good Q&A at the end. So a few definitions to start. Just the idea of analytics is this sort of, science of analyzing raw data to make some conclusions about that information. And this isn't new. We've been doing this, since the dawn of humanity, probably. But what's really changed is how we do this. Right? And one of the things that's really changed over the last, say, 15 years, 20 years, is that we now have big data. Right? That's these extremely large data sets that we analyze computationally to reveal patterns and trends and associations. Right? I'd say 20 years ago, there was only a few companies who truly had big data. And that's companies like Google and people like that who said, hey, we're the only ones that have these problems. But nowadays, everybody has big data. If you have a website that's fairly popular, just the clickstream data of, who's clicking where, when, you've got a lot of data that it's hard to deal with in regular, traditional sort of relational databases. Right? And another big thing that's come along is this concept of data science, where you sort of have to have some domain expertise. So you have to know something about the industry or the problem at hand. You have to have some programming skills and some pretty good knowledge of math and stats to be able to, utilize machine learning and apply it on this big data and come up with these conclusions. Right? And so that's sort of where data science intersects with these concepts of AI and machine learning and deep learning, and where big data sort of sits in there. When we talk about AI versus ML versus deep learning, AI is that idea that computer systems are able to perform tasks that normally require human intelligence. Machine learning is a subset of that, where the systems themselves that we build automatically learn and improve from experience. And one of the things that was largely theoretical until just a few years ago is the idea of deep learning, which is a special kind of class of algorithms where what we're saying is that we're going to use multiple layers to progressively extract higher level features from raw input. So the raw input might be just frames of pictures, and then we're sort of basically looking at it usually iteratively and saying, okay, this is a person's face. Oh no, this is Donald Trump's face or whoever, right? And so that's the kind of thing that we want to do. And so to try and compare these, I saw a nice analogy where we say AI is that idea of we can build a machine that can play chess based on the rules. Now you can teach it the rules, and then you can teach it some strategy, but it's got to take a programmer to code that strategy and add it in as more of the rules. Machine learning is where you build a machine that learns to play chess by analyzing past chess games, right? Games that were played by humans, right? So you're saying, hey, look at this past data and learn from it. And the more data we give it, the better those algorithms are, right? Deep learning is that new thing that it requires a lot more computation, right? Which wasn't really available until more recently. But that's where you build a machine that learns to play chess by playing itself, right? And running through more scenarios than anybody has ever played. And so that's the kind of thing where deep learning is sort of that newer, sexier type of machine learning that we see. When we talk about analytics in general, there's sort of different types of analytics, starting with descriptive analytics. This is what we've been doing for 30 years. I think probably the 90s is where this really started to get popular, where we started to see business intelligence and data mining and things like that. Oh, sorry. I've duplicated the slide. I'm not sure why. So descriptive analytics, it's very widely used. It's the simplest type of analytics. It's where we condense large data sets into smaller, more useful nuggets. And, we've been doing this for a long time. I did my first data warehouse project in, I think, 96, 97 in there. Shortly after college, I was working in a place, and we were just basically grabbing data from our mainframe and from some other sources and putting it into an Oracle database, right? And just to put it in one place, summarized, easy to get, right? We've been doing that for a long time. So that's descriptive analytics. The next level is more of predictive analytics, where we're doing some sort of forecasting, right? And where we're answering questions like this: what will happen if some condition happens? Right, so that's predictive modeling. Why did this happen? That's where we do root cause analysis. Look at data and say, well, let's find correlated data, right? Or forecasting, like what if the trend continues? Typo. Monte Carlo situations, pattern identification, alerting. There's all kinds of things that we can do where we're saying, let's use the history to predict the future, right? And so that's where most companies are now, right? We've all been collecting big data for a long time. A lot of companies are now trying to do this predictive. The next level is prescriptive, where we're really trying to say, what should my business do, right? This is a little more rare to find in a lot of organizations. Now, of course, there are companies that this is all they do is build software around this kind of thing. But the idea here is that we're going to simulate the future under various sets of assumptions, analyze all those scenarios, and then suggest what should the company do based on this. And so that's kind of the different levels of analytics. And I saw a really good sort of anecdote that kind of described it. And it was this idea that, let's say we have a lioness and she needs to go and hunt for creatures in, I don't know, the jungle. Actually, they're probably not in the jungle, but whatever. So she hires a data scientist because, I don't know, she's got money to spare and she's like kind of lazy. And so the data scientist, if they study the historical data and provide the lioness with a report of where did she find her prey in the last 6 months, that will help her decide where to go hunting next. That's descriptive analytics, right? That's, building a data warehouse of all the past data and making it easy to digest so that the, stakeholders can make good decisions, right? The next level is where the data scientist says, well, let me estimate the probability of finding prey at a certain place and time using some advanced machine learning techniques, right? That's more prescriptive analytics, telling her, hey, instead of you having to make the decision, I'm going to tell you where to find prey, where the probability of finding it at a certain place in time, right? The next level is where we do some sort of optimization. And that's where the data scientist says, here's the routes that you should run through the jungle to take the minimum effort in finding your prey, right? And so that's where you actually say, you should change your business of how you hunt to do it this way to take advantage, right? And so that's where organizations want to get to. There are very few that are really doing a lot of that, heavy duty optimization and simulation of all kinds of, options. But that's the ideal for a lot of companies, for data-driven companies, they call themselves, right? So I mentioned that, there's a lot of forward-looking trends. Whenever you go and Google, hey, what are the, big data trends or analytics trends or, anything like that, 2020, and it's always like way out. And so late last year, Gartner put out their hype cycle for AI, right? So artificial intelligence, there's a lot of things that are in there. And some of them have been around for a while and pretty mature, and others are brand new. And so what we find is that there's this sort of hype cycle that most technology goes through, where when it first comes out, it becomes super popular, but then you get to this sort of peak of inflated expectations where people say, oh, this is going to be the greatest thing. And then once they learn more about it, then they go into the trough of disillusionment, where they say, oh, this isn't the silver bullet that's going to fix everything, right? And then eventually we get to that slope of enlightenment into the plateau of productivity, where we say, now I understand, what is this technology good for? What is it not good for? And where will I be using this, right? And so a lot of times what we see when we do those sort of, hey, Google some trends, what we're seeing is a lot of like analytics and AI technologies that aren't even close to being widely used, right? They could be 5 to 10 years away from being really ready to go. And so if we look, the Gartner cycle, I know this is very small, but the circles that are sort of white circles, these are things that are, they're here now. So things like speech recognition, right? You got Alexa or Google Home or whatever, those things are working pretty well, but it's not like everybody built their apps on that. Now there's more and more people taking advantage of those kind of things. And it's likely that I don't have to build the algorithms myself, right? And GPU accelerators are all over the place, right? So there's some things that were already there at the plateau of productivity. We know what they're good for, we're using them. But then there's some things like these orange ones that are more than 10 years away, like autonomous vehicles. Remember how popular we were? Oh, this is going to be the greatest thing. And then they started crashing a little bit, and people started to say, wait a minute, there's some moral decisions about these, and now we're sort of in that trough of disillusionment where we say, we'll figure it out. But it's not here yet. It's more than 10 years from now before the road is full of nothing but autonomous cars, right? And so, all these different technologies are somewhere along this curve, and a lot of them are still fairly early on and still, at least 2 to 5 years away, and sometimes 5 to 10 or even more, right? And so that's all I wanted to say about that. I didn't want you to have to go and look through all these things. But that comes right from the Gartner report from last, I think it was last September or so. So let's concentrate more on trends that we actually see, right? So we have customers, we do a lot of AWS training, Google Cloud, Azure, as well as Cloudera and Databricks. So we have a lot of analytics customers coming through, not to mention, IBM and Oracle, and they have, all kinds of analytics offerings as well. SAP and SaaS, we got a lot of people coming through our doors for our classes. Now it's more virtual classes, but generally we have sort of a mixture of virtual and in-class training. And one of the big trends we find is that everybody's already over that hump of big data. Everybody's got big data. Everyone's doing some sort of analytics now, right? Not everybody has embraced AI that much. So if we kind of look, the percentage of adoption here over time, that sort of getting to that point of, hey, now we've all got big data. Now we're moving more into analytics, maybe even into AI. We're somewhere in here, really at the beginning of what AI can do. But big data, anybody who's got, like I said, a popular website already has that. And what I find is people coming into our classes, they've been collecting big data for a while. They're probably kind of putting it into a data lake. Either their solution is already up and running, or they're moving it to the cloud because the cloud fits nicely with the, the pricing model and the high availability and all that good stuff. And so we get a lot of people in our classes kind of moving into the cloud with their data lake. But that's been underway for a while. Right? Some other trends that we're seeing, students in our classes, if we look, say, 5 to 10 years ago, people were taking a class to learn Spark, which is part of, the Hadoop ecosystem, how we build, big data jobs. They were mostly, like, say, 10 years ago, just looking at it saying, should we be doing this? Is this, something of interest to us? 5 years ago, it was really a lot of developers coming through. They were either Java or Scala or Python programmers, and they were building batch jobs to do basically ETL. Take all this data, raw format, clean it up, and get it into a nice format that we can then do analytics on it. What we really started to see is more of a shift. Yes, people are doing that, but that's mature and they've been doing it for a long time. Then they started looking a lot more at streaming data, right? Little pieces of data flying in from, IoT devices or log files, instead of waiting for a whole log file as the log entries get generated, there's a lot of little pieces of data flying in. And so we started to see people take Spark streaming, pretty seriously. That's a way of using the same language and the same knowledge that developers would have for building batch jobs to build these little, sort of mini batches, so streaming. Now, we need somewhere to hold that stream of data. It could be millions of events coming per second, right? And so we see the rise of something like Apache Kafka, or in Amazon, they have Amazon Kinesis, which is a very similar kind of concept. And so those started to get pretty popular. Another shift that we started to see, especially if I look in our Databricks classes, it was a lot of, developers and stuff, and now it's a lot more data scientists. And those data scientists are doing sort of experimental stuff. So they're not just building programs that run on a, nightly job ETL, they're doing more exploratory analysis. And so they use something like a notebook, like Jupyter Notebooks, and they're connecting to live Hadoop clusters, and they're really wrangling data, they're cleaning the data and doing stuff with it. And so that idea of data science has really grown over the last, say, 5 years. And we see that the percentage of people who are data scientists is growing all the time. It's not growing fast enough, we'll find. And so we'll come back to that trend. But we are seeing more and more people who have those skills. Probably the biggest shift we've seen over the last, say, 5 years is the movement to the cloud. And not just analytics, like everything in IT is moving to the cloud, but certainly big data fits nicely with the cloud. If you think about it, we got really cheap storage there, which is, nearly infinite in scalability, right? You just add more data, and you pay for however much data you store in there. And it's very highly durable. They generally will copy it around to different data centers so that there's not a single point of failure, and it's highly available. And so what we see is that traditional sort of analytics companies like Hadoop vendors like Cloudera and Hortonworks, they had to really embrace those cloud strategies in order to compete with the big 3 public cloud providers. That's AWS, Microsoft Azure, and Google Cloud, because they each have their own managed Hadoop implementations. They started to take a lot of market share. We saw that Cloudera and Hortonworks ended up having to merge, so now they have sort of they're very popular if you're in that sort of hybrid where you have some things in your own data centers, you want to run some workloads in the cloud. They've really embraced that. But this movement of, large chunks of data into the cloud has been a big trend that we see and continues to be. Right? Another thing that we find is that hiring a data scientist is really hard. And remember we mentioned that they have to have some domain expertise. They have to know about the problem at hand. They have to have some deep statistics knowledge, and they have to be able to sort of hack and program, right? And so there's a lot that goes into being a data scientist. It's very multidisciplinary. And so hiring them is hard to do. There's, you can Google any kind of article and say, hey, is there a shortage of data scientists? And you'll see a million articles detailing exactly that. We have so many fewer qualified applicants than there are positions available. right? And so what most companies are finding is that it's easier to train somebody in-house, that's already, hey, I took a math degree and I've got lots of stats knowledge and I'm a programmer, so I just need to learn more of the machine learning and more about our domain. Or maybe they've been a statistician or something like that and working in a company, and then we have to teach them sort of the programming part, right? And so that's what we find in these classes, is that we're getting people who have 2 of the 3 and they just need to add the 3rd. Right? And so it might be easier to build a data scientist than to hire one, right? Now, I think that's changing, right? Just like any new technology comes out, it becomes, very specialized, and there's very few people that can do it. And then over time, you go to colleges and universities, and they're churning out people who have some of these skills, and they really just have to learn more domain expertise from that company, right? Maybe in the future, machine learning expertise will just be another part. You'll say, I'm a software engineer. That means that you have all this at your disposal. But I don't think we're anywhere close to that yet. Right? And actually, because of this shortage of data scientists, what we're starting to see is that people are saying, well, instead of trying to build a data scientist, why don't we just go and buy a product that's already got the machine learning algorithms all built and trained and everything? Right? And so this idea of productizing machine learning is a big trend that we see as well. Right? And so, use a product that has machine learning built in to make the data scientists available to the masses. Sometimes people call this auto ML, right? So it's like sort of automatic machine learning. There's a lot of options. If you look at the public cloud providers, they got natural language processing, image recognition, right? So instead of me having to go and hire a data scientist that knows all about these stats and the building algorithms to try and train and build a model and train it and run it and test it, validate it, I can just go to a cloud vendor and say, hey, here in your cloud storage, I've dropped thousands of photos. I want you to go index those and tell me the ones that are a photo of a person wearing sunglasses, right? And it should be able to go and figure that out, right? Because they've built these kind of models already. They've been using them internally at Amazon and Google and everywhere else. They basically just took those models that they built and trained and said, oh, here's an API you can call, for a price. Right? And so those things are available to us. Now, you can build recommendation engines, image recognition, all that kind of stuff. But not everything in data science is going to be that easy, right? There are certain categories that are popular enough that they built an API and made it available to you. So the concept of just saying, oh, we're not going to have data scientists anymore, I don't think that we're ever going to get there, right? But for the most common stuff, I think we're going to see a lot more things become APIs. And so just a regular developer, you can put these APIs in their hand, teach them how they work, and then they don't have to know all of the heavy duty math underneath what's going on, right? So that's another big trend. Some of the other trends that we're seeing is as data science moves from being exploratory type stuff into sort of a little more mature, what people are trying to do is automate as much as they can, right? So much of data science right now is exploratory and currently requires a human brain to do it. There are definitely parts of data science that are very mundane, repetitive tasks. And those things we should be able to automate them. And so some of the tasks that we typically automate are the basic ingestion and replication of data on a schedule, right? And then maybe validating that data, detecting things like typos or values that are missing, basically note those. Identify content that doesn't match this data model that we have, right? So what comes to mind for me is, I use AWS a lot. They've got a bunch of big data services for things like, hey, let's build a pipeline that starts with sort of a precondition that says, look in this S3 bucket, and if there are files in there, then let's kick this off. And what does it do? It says, okay, go grab those files, run through this, process of running a series of steps and cleaning it and cataloging it and all this kind of thing. Along the way, you might use something like AWS Glue, which is sort of a managed data catalog and ETL service. And it's actually got the smarts to say, hey, when I went and looked in that database, this table has a new column. What should I do with this extra column? Well, let me go back to my main sort of canonical data structure and add this new column. Or should I just ignore it? I can put the smarts in so that when it goes and crawls and it finds all my data sources, it says what to do when the data has changed since last time I looked at it, right? And so we can actually build that in and automate all that. And once we get these models built, we can actually automate the labeling of the data, the training and validating of the models, iterating study runs, the actual machine learning part, we can automate parts of that. And then finally, the creation of dashboards. If the whole thing halts and then somebody has to press a button to say, go build these dashboards, that's kind of stupid, right? So that's something that we can easily automate. And reporting in general, we should be able to automate. And so this idea of building kind of an automated data pipeline, this borrows a lot of ideas from DevOps, right? That idea of a CI/CD pipeline, developers say, hey, I check code into a code repository, and that kicks off a bunch of steps that automatically happen. They go and build whatever the artifact is. I put it into a production-like environment for testing. I run a series of tests. If everything's good, great. We've got a product that can be, put into production at any time now. And so that idea of automating all that is very, very attractive. And that's what we're starting to see on the analytics side a lot more, right? Is building that data pipeline, right? In AWS, we actually have a tool called Data Pipeline. That's one of the services where you can kind of stitch together all these different pieces and build that out and say, let's kick this off every night at 10 p.m., go and do a series of batch jobs and clean up my data and everything else. And so that's where a lot of companies are now, right? Or they're trying to get there, right? Now that automation and kind of those ideas from DevOps, this has sort of spawned a new term that you may or may not have heard of called DataOps. It started to pick up some prominence about 3 years ago. People started to talk more about it. And then there was a DataOps manifesto, and a bunch of people signed it. And we started to see that term. But really in the last year, it's become a very, sexy term. And it borrows from some of the concepts of DevOps, some of the ideas of the iterative and incremental, kind of programming of agile concepts, and that idea that we get from manufacturing, a quality control idea of statistical process control, where we're basically saying, hey, I've got this new product, but if it's not as good as the last product, then I'm not going to use it, right? And so it's really data driven. And so in DataOps, what we often see is that we've got kind of two pipelines going on. One is what they call the value pipeline. And so this is an automated process where we're basically taking data and getting value out of it, right? So, hey, everyone's got data. What I really need is insight, And so I'm going to run it through a series of steps that eventually get me, oh, that's what that data means, But it's not just a data pipeline, because it also brings in process to improve quality and reduce cycle times of data analytics. Because you have some data scientist that goes and explores some data and says, hey, based on my findings, we should be able to do this kind of analysis. Hey, we got all these credit card transactions, and I figured out a way to figure out, hey, are these ones fraudulent or not, right? Well, now it's time to automate that and build a product out of it so that, every time new transactions come in, we can say, is this fraud or not? And we flag it. Well, it looks like 80% probability it's fraud. Okay, flag it, right? And so that's the kind of thing that, you build that as an experimental thing. We test it out. We run through all kinds of validation. And once we have it, then we put it into production. But then we don't just say, well, that's it forever, right? We always want to continuously improve, right? That's part of the DevOps ideas. And so really there's orchestration, there's two pipelines. There's that value pipeline that the data goes through, how data moves through a process to provide value, but there's also the innovation pipeline. And that's this one going south to north here on the diagram, where we start with an idea and then we develop it and then eventually get it in production. But only if, we look at the statistics and it looks like it's going to be at least as good as what we were doing before, right? And so this is really where we're starting to see a lot of, I had a discussion with a customer on Thursday of last week where he basically dropped the DataOps buzzword, and he didn't want to. He said, I hate to use a popular buzzword right now, but he's like, we're kind of into DataOps. And I was like, I know exactly what you mean, right? And so this is what we're starting to have those conversations with companies that are really data-driven, right? Most enterprises are not quite here. They built their data warehouse. They're grabbing the data, pulling it out of various places. They might have a data lake for more ad hoc kind of stuff, and they have data scientists doing ad hoc stuff, but they might not be productizing it that much, or they might not have a full like data ops kind of approach yet. Right? And so that's sort of where some of the more data-driven customers we have are. Now, having said that, we've got customers at every end of this spectrum, right? There are companies that are just AI companies and they've been doing AI for 10 years, right? But I'm looking at, the bulk of our enterprise customers are not at this point yet, but it's good to know where those companies are going and where you might want to be in that. So if you want to learn more, there's a lot of places to go, right? So if you're sort of more on the Hadoop side, we have both Databricks and Cloudera classes. They start with usually kind of an intro to Hadoop and, learning Spark, but then they go on from there to talk about some of the other Hadoop ecosystem projects. All of our cloud vendors, so here we are partnered with the big three. Typically, if you want to take a course like the Big Data on AWS class, you better take some, previous AWS classes to learn about AWS, and then you learn about their analytics. Google Cloud actually does a pretty good job where they've got a 4-day data engineering class. We typically take the 1-day, Google Cloud fundamentals first, just to get the basics of Google Cloud, and then jump into that 4-day. And that's a great class. And what we're finding is that Google Cloud is becoming very popular because they do a great job of analytics. If you look at the big three, like AWS has quite a bit of market share. Azure's been steadily growing. Google Cloud is very much a third place. But if you look just at analytics and machine learning, they've got a really, really good offering, and they've got a lot of market share of that part, right? And then, we have, like I said, over 25 other vendors. So, if you're looking for business intelligence training, IBM Cognos or Tableau or any of those kind of things. When it comes to analytics, you've got SAP, we got SAS, there's all kinds of Oracle, there's all sorts of analytics training in there. So we threw all these out. I think that Michelle was going to put these into the chat. Have you done that, Michelle?
Yeah, they're in the chat now.
There they are. So, whatever it is that you're looking for as far as classes go, we should have you covered. And if you're looking for something more specific that you don't see here, we have some classes that we run that we actually don't even have on the website yet. There's some like, hey, I want to learn Python for data scientists. We have a class like that. We run it. We don't have public classes for it, but we run it in private situations. So we do both public training and private group training. And, under normal circumstances, we can either do it, send somebody to your office, or, you can come into ours, or we can do it virtual. And right now we're doing all our classes virtual. But luckily we've been doing virtual training for 8 years, so we're pretty good at it. Zoom is the basis of our IMVP platform, but it's a lot more than just that. And we have a promo right now. Maybe Michelle, you can tell us about the promo.
Absolutely. Really excited to talk about our Refer a Friend promo. So if you take a class with us and then after your training, refer a friend or a colleague, you'll get up to $100 Amazon gift card and your referred friend can save 15% on their course. I'm going to post the link to all of those details in the chat as well.
Okay. So if they sign up, they get a discount and you get a gift card.
That's right.
All right, cool. That sounds all right. So that's all I really prepared. You know, I figured, well, let's leave like 20 minutes for questions. And so that's where we're at. So whatever questions you have, drop them into the Q&A and we can cover them off.
While those questions come in, I just want to remind everyone that we've recorded this session and we'll send a copy out to everyone by the end of the week. I'll post those training links in the chat again in a few moments after a few questions come in. And as always, you can reach out to us to learn more. So go ahead, find that Q&A icon at the bottom of your screen and ask any questions you might have.
Okay.
Myles, it looks like you may have just given a thorough presentation, covered all the questions before they were even asked. I posted all the links to those relevant classes in the chat so you can jot them down, copy them, check out our website to learn more. I also posted our promo link again one more time. If there are no questions, I think we can wrap up here. Thank you so much, Myles.
Rob mentioned the Azure classes. So yeah, any of these, if I just click on it, this will take us to our website. And so I just sent it to the main level of Azure classes, but if you go down the side, there is a grouping here called Data and AI. And so there's sort of 5 main classes that Azure has. The AI 100 is very much AI stuff. The DP is the data processing ones. And so there's the 200, which is implementing an Azure data solution, and then the 201, designing. So very often in the Azure classes, that's what they do. They kind of, they try and make a distinction between implementing and then designing. So it might be backwards to some people, but the implement is learn the basics of how to like launch stuff. And then the designing is, hey, how do I really put these pieces together? So that's more the advanced part. And then they have like a combo designing and implementing. And so it's like basically the 2 classes together. So that's what the Azure curriculum looks like. Courtney is asking a couple questions. Second one first. Google or AWS for data analytics? I already hold AWS Cloud Architect. Yeah, so a lot of times what people are really interested in is having multiple certifications from different vendors, right? And I think that's a very good idea these days. You know, I know that, if I'm hiring somebody, I want somebody with experience first, right? But if I'm looking at 2 people that have experience, the ones that have the certification, that tells me, well, they're serious about their career. They were able to pass these exams, and some of these exams are not easy, right? So certification has a real value, especially when you're looking for jobs. But where it's really interesting is where you have multiple certifications from multiple vendors, right? And so the AWS, Cloud Solution Architect is pretty popular one, but it means, you know the basics of AWS. You can go further and get the AWS Machine Learning. That's a specialty certification. It's, we have a nice class for that. Assuming you know a little bit about AWS, you can take this 4-day class called the Machine Learning Pipeline on AWS. That'll get you pretty much ready for that specialty exam. But if you want to go to a second cloud vendor, what I would suggest If it's on the data and analytics side, I would say Google, because that's the second cloud that people are using. Like, we got a lot of customers who are AWS customers, have been for 8 years or something. Most of their infrastructure is in AWS. And now they say, we got a lot of data sitting in S3 buckets. We're going to move it over to Google Cloud because we prefer their stack of analytics. And so that would be where I would concentrate. Now, if you look at the Google Cloud side of things, here we have these learning paths. I'll go find the Google Cloud one. Here it is. So we got these PDFs that kind of show, what the paths look like. So here's the cloud data engineer. We typically say take one of the fundamentals classes, either the core infrastructure or more likely this one, the big data and machine learning 1-day class, then the 4-day data engineering. That will pretty much prepare you for the professional data engineer exam, right? And it's pretty good. It's not an easy exam by any means, and it helps if you've got a lot of big data experience, so that when they talk a little bit about their various services, some of them are things that you've never seen before, like BigQuery is kind of a different animal than what everybody else has, but some of them are basically just a Hadoop, but it's a managed service that they have for you. And so this 4-day class kind of covers them all pretty well, and the machine learning piece as well. So that's the best path, I would say. Take that 1-day and 4-day. You take them in the same week. They're typically, scheduled together. Or I would, if you're taking them virtually, then you may as well take the 1-day, ruminate on that a while, then take the 4-day class, and then, basically you're ready to go for the engineering professional certification. Now, the other question was data engineering versus data analytics. I think that's an interesting one. In Google Cloud, they make a real distinction between cloud engineer is somebody who's, really in there setting up the infrastructure and then using it. A data analyst might be more of, not deeply technical person. They're more on the analytics side. They might be able to write SQL, but they're not real programmers. They're not administrators, and so that's more, it's an analyst rather than somebody who's actually, launching stuff and running things. They might be just connecting to, BigQuery and running SQL queries. All right, so that's a couple of good questions there. If you have any other questions, I'll throw my email address here. It's myles.brown@techdata.com. Feel free to send me any questions. If it's questions about a specific class, I might eventually forward you on to a salesperson to help you out. But otherwise, I can answer a lot of the basic questions around that stuff. So I think I'll wait just a couple minutes and see if there's any other questions coming in. All right, well, looks like we kept it in under an hour. Whew. Good stuff.
Thank you, everyone, for taking some time out of your day. You know where to reach us if you do have any questions. As always, thank you, Myles.
Excellent. Did you stop recording?